Hi everybody, this is going to be our chapter 5. We're doing triangles. In our first little section here, we're going to classify triangles by angles. So we're going to start with acute triangles. Acute triangles mean all of your angles are less than 90. An obtuse triangle means that one angle is greater than 90, so that angle right there is going to be greater than 90. Okay, a right triangle means that you have a right angle. If you don't know, that box right there means right angle. An equiangular means that you have three congruent angles, or three angles that are the same. All right, so now we're going to practice and see if we can classify these. So the first one is CDE. Okay, so there's that triangle. We see that we have this 90 degrees right here, which makes this one a right triangle. All right, next we have BCE. This angle right here is going to be greater than 90, so this one is an obtuse. All right, next we have ABE. We can see that all of our angles have this symbol, which means they're all equal. So this is an equiangular. All right, next we have BDE. So B to D to E. Well, this angle right here is clearly greater than 90, so this one's going to be an obtuse angle. And last one, we have CFE. All of those are less than 90, so this one gets to be an acute triangle. Now, we can also classify triangles by our sides. So if we have three congruent sides, that right there is an equilateral triangle. We can have two congruent sides. We call that an isosceles. Or no congruent sides, we call a scalene triangle. All right, so let's check these out. JKM. So there's J to K to M. All right, well, this is 1, and this is more than 1, and that also looks more than 1. So this one we're going to call a scalene. All righty. KLN. K to the L to the N. Okay, so we know this side and this side are equal, so that is going to be an isosceles. Okay, last one here is going to be JKN. They all have one tick mark on each, which means they're all the same, so that is an equilateral. All right, so now let's classify it by our angles and by our sides. Okay, so for this one, we have two congruent sides. So by sides, we are going to call that an isosceles. Okay, it also has a right angle. So by angles, this would be a right triangle. All right, looking at 10. This angle here is 114, so this would be an obtuse triangle. And because we don't know anything about our sides, we're going to call this a scalene. If it doesn't say, we can't assume. All right, by angles, we can see all of these angles are the same. So this was an equiangular. And by sides, all of our sides are also the same. So this was an equilateral. All right, let's do some more practice here. So by angles and by sides, here none of these look to me to be obtuse, so we're going to call this an acute triangle. And all of these sides are different, so again, that is a scalene. Here, once again, we have a right, so by angles, this is a right triangle. And again, it looks like all of our sides are different, so this would be a scalene. This angle here is bigger than 90, so because it's bigger than 90, we call that an obtuse triangle. And this side are equal, so two equal sides we call an isosceles. All right, so now we're going to use what we know here, or given here, to classify each triangle by its angles and by its sides. So I'm going to do a couple, then give you the answers for a couple. So U, Q, R. U to Q to R. So by sides, we can see we've got two ticks. So that makes it an isosceles. And we have an angle here greater than 90, so this would be an obtuse. Next one, we have RST. R to S to T. All right. We know that this side right here is 16. We know this is 8 and this is 8, so that's also 16. And we know that, or we can conclude that this side is also 8. So 8 and 8 makes 16. So that would be an equilateral. And we have 60 degrees here, 60 degrees here. If we know that all of our triangles add up to 180, that would take out 120, which means this one also has to be 60. So this would be equiangular. Now, if you've noticed, every time we have equilateral, we also have equiangular. That is the same every time. All right. Last one we're going to do here, SRQ. So here's S to R to Q. We have our right angle right there, so that's going to be a right triangle. And we have an 8 and a 16, which means we are going to have a scalene. All right, I'm going to give you the answers for 18, 19, and 20. 18 is going to be an obtuse isosceles. 19 is going to be, again, equiangular, equilateral. And 20 is going to be a right scalene again. Okay, so if you've tried any of those and you have a differing answer, let me know and we can work them out together. All right, so for this one, we have to go back to our distance formula and we have to perform this to see by sides what are these or how can we classify them. So we have to do JK, KL, and JL. So let's start with JK. If you've forgotten the distance formula, put it up here. So when we do the distance formula, we are going to take our x's, doesn't matter which one, x1, and we're going to minus it from x2, square that. We're going to add to that whatever one you did for your first one, we're going to do for the second one. So y1 minus y2. And once again, we're going to square that. Minus insides, add the outsides. So let's try JK here. All right, so I'm going to start with my x's here. So I'm going to have -7 minus -9, so it turns into a +9, squared, plus -7 minus 1 squared. that will get me to 9 minus 7 is 2. 2 squared is 4. Plus negative 7 minus 1 is negative 8. Negative 8 squared is 64. So my final answer for this will be square root of 68. All right, now I'm going to do the next one, KL. All right, so for KL, again, I'm going to start with my x's. So negative 9 minus negative 1, so it'll turn into a plus 1 squared. And now I become 1 minus negative 1, so it'll turn into a plus 1 squared. Negative 9 plus 1 is negative 8. Negative 8 squared is 64. 1 plus 1 is 2. 2 squared is 4, which also gets me to 68. Square root of 68. All right, last one here. We have LJ. Or JL, doesn't matter. All right, I'm going to do this one down here. So I'm going to do negative 7, and again, minus negative 1, so that'll turn into a plus 1. Oops. Squared plus, I'm going to have negative 7 plus 1 again. Negative 7 plus 1 will give us negative 6. Negative 6 squared is 36. Plus, same thing here, 36. The square, 36 plus 36 gets us to 72. So let's see what we have here. We have 68, 68, and 72. Two of my sides are the same, which means this one is an isosceles. All right, you're going to do the same for 22 and 23. I'm going to write down the answers for what you should get for each side, so you can check yourself here. So when we do this one, JK, you should get the square root of 41. KL, you should get the square root of 85. And finally, LJ, you're going to get the square root of 130. None of these sides are the same, so this one is a scalene. 23 here, JK, you're going to get 260, square root of 260, I should say. KL, you're going to get the square root of 130. And JL, you're going to get the square root of 130. JL and KL are the same, which makes this triangle an isosceles. Again, take your time, work through these. Distance formula is not going away. Make sure you get these answers. Last thing we're going to do today is solving triangle sides with algebra. So, we're going to use what we know about our sides and see if we can solve some equations. Here we have an equilateral triangle. So what we're going to do is we're going to solve for both x and our y, knowing that because it's equilateral, all of our sides are the same. So here's a number. I'm going to use that number for both of these. So I'm going to set these two sides equal first. So I have 3x plus 1 is equal to 49. Once again, this side is the same length as this side. So they're equal. So I'm going to subtract 1 from both sides. That gives me 3x equals 48. Divide both sides, so I get x equals 16. I'm going to do the same thing for the other one. I know that red side and this red side are the same, so I'm going to set them equal. So I have 18. 18y minus 41 equals 49. I'm going to add 41 to both sides, so that gives me 18y equals 90. Divide both sides by 18, so I get y equals 5. Here they want us to find x and the measure of each side. So let's go ahead and find x. With x, you can set any of these sides equal. I am going to choose to set this side equal to this side. But again, you could have chosen any of them. Your x will still come out to be the same. So I have 10x minus 6 equals 7x plus 18. I'm going to minus 7x over. So I have 3x minus 6 equals 18. Add 6, so I have 3x equals 24. And divide both sides by 3, so I get x equals 8. No matter what sides you set equal, x should equal 8. Now I'm going to plug that in and see what I get. So for RS, when I plug that in, I'm going to get 12 times 8 minus 22. 12 times 8 minus 22 is going to get me to 74. Now again, we know all of these are the same length, so what I can do is I can say, okay, well, if RS is 74, then ST should also equal 74, and RT should also equal 74. You can plug those in just to double check to make sure that your x is correct, but they should all come out to be 74. 3 is again a repeat of what we just did for 2, so I'm going to give you the answers here. Again, it's an equilateral triangle, so you can set any of your sides equal. When you solve for x on number 3, x should equal 13, which means all your sides, when you should plug that in, all your sides should equal 27. Looking at 4 here, 4 is an isosceles triangle with DE equal to EF. So when we have that, we're just going to set those two sides equal to each other. So I have 8x minus 13 equal to 5x plus 17. So now I'm going to go ahead and solve. So I'm going to minus my 5x over. That gives me 3x minus 13 equals 17. Add 13. So that gives me 3x equals 30. Divide by 3. So x equals 10. Now again, they want the measure of each side, so I'm going to plug that in. So let's start with DE first. So I have 8 times 10 minus 13. 8 times 10 minus 13 gives me 67. I know that DE is the same as EF, so that means EF should also be 67. Again, you can plug that in. 5 times 10 plus 17. Finally, DF, I'm going to have 10 plus 21, which gives me 31. 5 is the exact same as 4, so I'm going to give you the answers here. For this one, x equals 27. And when you plug that in, WX will equal 85. XY is also equal to 85. And our sweet friend WY is going to be equal to 104. All right, this is the end of today's notes. If you've got any questions, let me know. That was a long one. Do the assignment listed above.